Alright, we have started to implement asynchronous queue support for our project in the previous video, and we basically implemented the producer and the consumer pattern here. But now it's time to add some queue operating support for our helper functions as well. So we have a runFD time, which is going to add the timestamp into the frame. Then there is a show frame, which is operating on the queue, and the run blocking function is going to do some phase detection on this frame. First of all, let's just quickly go through these functions and how they can operate on the queue. So runFD time is here. I'm going to create a async IO create task with add timestamp to frame function. I'm passing this frame to the add timestamp to frame. Let's just go there, and as you see, there's a single change here that we are operating on frame object 1, because keep in mind that when we are producing the frame reading from the camera, we are putting the frame to into the queue. We put the tuple or tuple object, and the first element of this object is the camera name, is a string effectively, and the second is the frame itself. And that's why we need to operate on the second element of this object, so frame 1. And we are returning the frame from this the add_datetime.py file, from this add timestamp to frame function. And then we are waiting through this task. And remember that it's returning the frame, and we are putting back this updated frame to the queue. Then we are just indicating that we are done with adding the timestamp. Secondly, we need to implement the show frame with a queue support. Let's just go ahead to this show frame function, and now it accepts a queue object, and we are getting the frame from this queue and showing this frame. So frame 0 is a camera name, and frame 1 is the actual frame itself. And this is a type hint in Python, so this queue object is a type of Liefer queue, which we were implementing in the previous video. And the next thing is running blocking func. The change here is as the same. So with process pool executor, we are getting back the frame from the queue. We are running this phase detection on run phase detection function and operating on the second element of the frame object and returning back this frame. That's it for this thing. So we are waiting from this loop running executor, and we get back the frame. We put back the frame to the queue and indicating that we are done with async IO sleep. So this is basically our queue management code change for our project. Again, you can grab this code change from the GitHub. I'm going to put in the video description as well. And let's just quickly test it. So we are building, we are up and building. Then this is another way of entering to the container. Then the Python main.py. Nice. So it started. It seems to be that something wrong. So this is basically how you can face some queue management issues, and the first of them is that when the queue is full, it's going to freeze, as you see. So we are going to fix those issues in the next videos, but I want to show that if you didn't do something correctly, even managing this queue, entering the queue, getting back from the queue, and putting something to the queue, you will face some this several issues with queue management. Even it's a asynchronous queue, things getting worse as they of course. So yeah, that's it, and see you in the next video.